Alright, welcome back. So we've got more on rates of change today. Objectives are to estimate accumulated amounts from functions of given rates, accumulation and loss, and estimate and interpret rates of change, their integrals and derivatives at specific instances in time, given only tabular data. Okay, so we've got a right cylinder of a radius of 12 and a height of 4, as well as a table of data that shows the water that is being pumped into the pool in cubic feet per hour. We've also got a function, RT, which is the rate at which water is leaking from the pool. At the time t equals 0, the pool already contains 1,000 cubic feet of water. So first I want to use a midpoint Riemann sum with equal subintervals to estimate the total amount of water that was pumped into the pool from 0 to 12. What do I have to do?
So we find the midpoint for between like 0 to 2 to 4, 2 to 4, 4 to 6.
I need 3 subintervals of equal length from 0 to 12.
Oh wait. Oh, so we use 2, 6, and 10.
Right. Okay, so first subinterval, second subinterval, third subinterval, and then midpoint set 2, 6, and 10. Okay, so how can we set it up?
And then so P2 times 4 and P6 times 4 and P10 times 4.
Okay, I see what you're doing. So, this is the integral from 0 to 12 of pt dt is roughly equal to, so you said our base, 4 times p at 2, plus 4 times p at 6, plus 4 times p at 10. Okay, that all looks good. So when we substitute, what's that going to be equal to?
So 2 times 46, no, 4 times 46, 4 times 57, 4 times 62.
Okay. This one is with the calculator, so I'm going to pull that out. I think I'm going to factor out the 4 and just add this 46, 57, 62 together. Oops, 46 plus 57 plus 62, all times 4, is 660. What are my units?
Feet. Wait. Wait. So PT is it's cubic feet.
Cubic feet of water. Okay. And what does PT represent? So, what is this water?
That's the total water that pumped in.
Okay. It's pumped into the tank. from t equals 0 to t equals 12. And that is seconds, minutes. What are my units for t?
Second.
Not seconds.
Oh, hour.
Hours. Okay. Any questions on part A?
Nope.
Okay, for part B. I need to calculate the total amount of water that leaked out of the pool from 0 to 12.
So that's integration from 0 to 2. Oh, RT. And then we use calculator.
Okay, RT. RT what?
RT dt.
dt. Okay, and I can't use a calculator for that, so I'm going to throw this in y equals in case we need it later. 25 e raised to the negative 0.05 t. I'm going to close that. That way when I go to use the integral, I don't get any weird parentheses issues. I know you can graph it if you don't close the parentheses, but when we start to use it in the function, sometimes it can get whack. So math 9 for integral variables, y variables, function y1, and we're integrating in terms of x from 0 to 12. Okay, 225.594.
Yes. Cubic feet.
Cubic feet of water. And what happened to this water?
Leaked out.
Okay, leaked out of the tank from t equals 0 to t equals 12 hours.
Yes.
Okay. Then we're going to use what we got from part A and part B to estimate the volume of water in the pool at 12 hours.
So
Okay.
at 12 hours, we subtract A to B.
Okay, we'll need to do a little bit more than that. 1 second. 225.594.
Oh, plus 1,000.
Right. 594. 225.594. Okay, so I'm going to set up my general form first. So this is the volume of water in the tank at time 12 is equal to what?
1,000 plus integration from 0 to 12 pt dt minus integration from 0 to 12 RT dt.
Perfect. Then we'll just substitute in. 1,000 plus 660 minus 225.594. Is 1434.406. And what are my units?
cubic feet.
Cubic feet of water, and what does this water represent?
The water at T equals 2. Total water.
Is in the tank at
T equals to 12.
T equals 12 hours. Okay. Oh, it does say round your answer to the nearest cubic foot, so I don't need this decimal.
Oh, so it's 2 to 14, yeah, 34. No, 1434.
Okay. Then part D. Find the rate at which the volume of water in the pool is increasing at T equals 8 hours for the first part.
So we have to differentiate.
What are we differentiating?
The V equals pi r square h. V equals pi r square h.
You're not wrong, but we don't have formulas for H. So we might need another
Oh.
formula for volume.
Oh, Bt equals P integration 0 to T Pt dt minus integration from 0 to T RT dt.
Plus what?
Plus 1000.
Plus 1,000, because we started. Okay, so then what would the derivative be?
PT minus RT.
Okay.
Oh, it's simple.
And then we need to find that at 8.
So P8 minus R8, which is 60 minus, we have to plug in the number in R.
Okay, I'm going to write that here before I go to my calculator. So that's P of 8 is 60, you said? Minus
60 minus 25 e to the, wait, what do you get if you multiply? 0.4 minus 0.4.
minus 0.4 times T. Okay.
Oh, we already multiply by.
Yeah, we did. Okay, my bad.
That's the answer. Oh, and then unit is cubic second per hour. So dv over dt is equal to pi r square h pi r square dh over dt.
Okay, and then dv over dt was 43.242.
Mm-hmm.
So I'm going to divide that by my 144 pi. 0.096. And what are my units?
Feet per hour.
Okay. Alright, so before we made our changes, we had 2, 2, 1. Okay, we did have v prime correctly. An equation relating dv and dh over dt. Okay, we did not have that correct. Did not have that one, but we did have our units correct. So that would have been 7 out of 9. Alright, any questions on this one?
Nope.
Okay. So homework again. We'll be doing the first half of the free response, minus the one that we just did. So that'll be due on Friday at 9 a.m. I'm told that GradeLink is frozen, but I'm not missing anything from you, so you're okay.
Yay.
Both for this class and for physics.
Yep.
Okay, so thank you very much, and I'll see you tomorrow at 12:05.
Bye bye.
Goodbye.